Feeling my way through the darkness, guided by a beating heart. I can't
Hi
tell where the
scholars, we're going to look at a couple of problems where it's helpful to think about using the measuring model that we've learned about. So for example, Esther has a ribbon that is 4/3 of a yard long. So I'm going to actually interpret 4/3 as 4 of these things that are thirds of a yard, right? I have 4 thirds. So if I wanted to make a picture, I could imagine here's 1/3, here's a second third, here is a third third, and here is a fourth third, right? And all these are equal size. They should be equal size. So here's a third, here's a third, here's a third, and I have 4 of them. So that's one way I can interpret 4/3. Okay, great. Let's keep reading. If she cuts the ribbon, the whole ribbon, right here, into equal pieces, and of course they're going to be equal, each measuring 1/15 of a yard, the question is, how many pieces will she have? So the idea is that here's something is 1/15 of a yard, right? And we want to say how many of these things fit into this whole length here, right? This whole length of ribbon. And so we can do that by saying, well, how many 1/15 pieces are there in this piece, 1/3 of a piece, right? We can sort of think about it that way, and to answer that question, we can use a proportion, or we can just reason about it. And in fact, 1/15, really the question is asking, or what we're asking ourselves is 1/3 is how many of these 15ths? And we can reason about it, say, well, actually it's 5 of these 15ths, right? Because 3 times 5 is 15, and 1 times 5 is 5. This right here is proportional reasoning. So in either case, we can say that 1/3 is 5/15. That means 5/15. That means you can fit 5 of these things that are 15ths into 1/3. Okay? Let's do it. How many can we fit in? Let's make 1, we can fit in 2, we can fit in 3, we can fit in 4, and each one of these small pieces is a 1/15. Since we have 1, 2, 3, 4, 5/15, it's going to equal 1/3 of a yard. So now we can see sort of quickly that, well, 5 of these 15ths fit into 1/3 of a yard. So how many are going to fit into the second third of a yard? Well, that was 5. This, right, we could do it, but really this is just going to be another 5. This is going to be another 5. This is going to be another 5. So how many 15ths fit into this whole yard right here? We just add them up. 5 plus 5 plus 5 plus 5, and we get the answer of 20, right? So that's the answer, 20/15. Now, we could also have done this problem, set this problem up a little bit differently algebraically. So this right here is a nice way of thinking about it. Algebraically, believe it or not, this question is really asking, let's actually, well, no, I'll do it on the same page. 4/3, this is what I have to measure, and I'm using a ruler of 1/15 length. This right here, this setup, is identical to all this reasoning that we just did, right? 4/3 measured using a 1/15 ruler is the same thing as saying how many of these 1/15 would fit into this 4/3, and we found out that there were 20 of them, right? 20 of these small things would fit in. So 4/3 divided by 1/15. We could do this in many different ways. We could use our flip, multiply, whatever algorithm thing, right, where you flip it and whatever, but that's not really that interesting. Let's instead say, I really wish I could measure the thirds with the 15ths, right? So let's actually try to find, just moving from here, let's try to find a common denominator between these two fractions that are within a larger fraction, right? So 4/3, well, 4/3 is really nothing more than 20/15, right, over 1, right? Let's make this one a big fraction, over 1/15. And since they're the same here, we can just kind of ignore them. And I'll be darned if what's left over isn't 20/1, otherwise known as 20. So our answer in a couple different ways is 20. Let's take a look at one more example. This example has to do with Theo. In the past 1.5 years, Theodore grew an average of 2/3 of an inch each month. Okay, so we have 2/3 of an inch every month. Today he is 52 inches tall. How tall was he 1.5 years ago? Okay, so 1.5 years ago, the question is how many months? Well, in 1 year, there's 12 months. So in a half of year, there will be half that amount, 6 months. So total, there's going to be 18 months in 1.5 years. Okay, and so this question is really asking, if I have 18 of these months, there's 1, there's 2, there's 3, so let's actually say here's the 18 months, right? There they all are, all the way up to 18. Okay, we assume it works, right? Da, 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 da. And we say each one of those is worth 2/3 of an inch, right? For Theo. So let's actually, right, this will be 2/3. So each one of these things is worth 2/3 of an inch. Every month he does 2/3. The second month he does another 2/3. The third month he does another 2/3. And we want to say, how much did he grow in that 1.5 years? Well, we could add it up 18 times, or we could just use multiplication, right? 18 times 2/3. That's really what this question is asking, right? And we can do this in a couple different ways. I could either, if I wanted to, we could multiply across, right? So we could say 18 is really 18 over 1. 18 times 2 is 36. 36, 1 times 3 is 3, which is 36 divided by 3. We know our multiplication tables is 12. Or if I wanted to go a different route, I could from here, right? So this is one way of doing it, and this is correct. Okay, I could from here say, well, look, 18 and 3, there's a common factor there, right? So in fact, instead of 18, 18 is really another way of writing 6 times 3, right? Remember when we were learning how to factor? And there's a 3 on the bottom and a 3 on the top, so they can actually cancel. Goodbye, so long. And what do I have left? I have 6 times 2. And math is so nice and consistent. Okay, so that's another way of doing it. You're both basically doing it a similar type of way, but that's another way of doing it. So that's our answer. How tall was he? Well, that's part of our answer. In the past 1.5 years, he grew 12 inches. That's what this number means, right? Because he grew 2/3 and 2/3 and 2/3 18 times, right? And now he is 52 inches. So today he's 52 inches. 52 inches. In this time, he grew 12 inches, right? So the question is, how tall was he? Just cross that off right now. How tall was he before he started growing 12 inches? Well, he was obviously shorter because then he grew more to get taller. So in fact, this is going to be 52 minus 12. 52 minus 12 is 40 inches. So this right here is your final answer. That's how tall he was 1.5 years ago. And if you wanted to check, you could say if I start with 40 and then I add 2/3 and 2/3 and 2/3 every month, 18 months, you're going to get to 52 inches, okay? Now, often in these types of problems, it's very helpful to, if you can get to it in one way, so if you can get to it algebraically, to make sure it makes sense, to think about it in a different way, which is challenging, right? But it's very helpful. And it's also helpful to, once you have an answer, you say that he grew 12 inches, you say that he was 40 inches long, to sort of check your work, right? To see, is it in fact true that 40 plus 18 times 2/3, does that in fact equal 52, right? That's a question you could ask yourself. And you could actually calculate that. So this is a check. And if you have time, when you have time, it's really important to check your work as well.